However, we do not want to use a formula for perimeter because this is actually not just a rectangle, it also has a divider in between it. We may want to label the sides though. Normally with a rectangle we have lengths and widths. Again, it doesn't really matter which one you label, but let's go ahead and label this whole side to be the length, this whole side to be the length, and then each of these would represent a width. Normally, perimeter is 2L plus 2W, but since we have this subdivider in between, it's actually going to be a little bit different. So let's think about this. The perimeter of this shape, or where I'm going to need to fence, I need to fence here and here, which will be L plus L is 2L, plus I have actually 3 W's this time, right, that are going to need fencing. So W plus W plus W will get me 3W. So we're not using the actual formula for perimeter, we're kind of creating our own just by looking at the L's and W's we got. Now we'll plug in 1800 for P. Okay, so that's as far as we can go with the given information. Let me read the question for part A. What are the dimensions of the field with the largest area? So largest area means we're going to maximize the area. Largest, greatest, maximize. Maximum, which is our vertex of a quadratic. Right now we don't have a quadratic, right? We also don't have anything that talks about the area. What is the area of a rectangle formula? We're finding the area of this whole rectangle, Ashley. Length times width. Now the problem is we don't know what L is and we don't know what W is, right? But just like we did in that homework question that we just went over, we can actually solve the first equation for L or solve it for W, and then we can use substitution to plug that in so that we only have one letter instead of 2. Okay, so you're going to solve for a single variable. It really doesn't matter if you solve for L or if you solve for W. When I did it, I solved for L. So let's go ahead and do that. So we'll solve for L. So to solve for L, I need to subtract 3W. I will get 1800 minus 3W equals 2L. And then divide everything by 2. And you can make that 1.5 if you prefer. I know a lot of you prefer a decimal than a fraction. I'm going to flip that around, make it L equals 900 minus 3 times W. So kind of like on the homework where I had said solve for C and then plug that expression in for C. We're now going to take this, we're going to plug it in for L, because L equals that. So we can replace L with that expression. I will want to use parentheses. So 900 minus, let's just change it to 1.5, because I know you guys like that better. 1.5 W times W. And to get this in a quadratic form, I will distribute. Now we are going to distribute backwards since the W happens to be at the end instead of in the front. So we get 900W minus 1.5W squared. So that's the quadratic equation to represent area of this shape. We want to maximize it. So to maximize it, we know that that means we have to find the vertex. If you think about this, this is a negative quadratic. So to maximum, we need to find the vertex. You may want to rearrange it so that it's in the ax squared plus bx plus c. So let's rearrange this. So we have negative 1.5 w squared plus 900w. That way you don't misidentify what a and b are. You don't have to do that if you can see it the other way. And then we'll use our vertex formula. So we'll have negative 900 divided by 2 times negative 1.5. And again, if you want to type this in your calculator as is, you're just going to put parentheses around the whole denominator. So it would be negative 900 divided by, and instead of actually typing it in the way you see it here, you'd want to put parentheses around that whole thing. So b divided by parentheses 2 times negative 1.5. We'll get 300. Or you could multiply the denominators and then divide them. Now, think about what we just solved for. We found this value, just like we normally find the x value, but this is the independent variable that we're plugging in. So this is standing for w. So that's not the answer to the area question. That is going to be the answer to the dimensions. Okay. This one does say dimensions. This one says the area. So we will have to find the lengths. We also have to find the area. So it's up to you whether you want to take and plug 300 back in here first, or if you want to plug it back in here. You're going to get both parts of the answer. So let's just do it in this one first. Let's find out what the length is, since that's what part A asks for. So we'll plug in 900 minus 1.5 times 300. Or 3 halves times. That'll get us 900 minus 450, which is 450. So to answer part A, the length is 450 feet, and the width is 300 feet. If you want to write it as dimensions, you could just put 450 feet by 300 feet. But if you'd rather write them out separately, it's fine. Now the area, you could actually just multiply length and width together. It would be faster. 450 times 300, and we'll get our answer. But you also might want to, just to make sure you did it right, plug the 300 that we got back into the area function and make sure you get the same answer both ways. So that'd be negative 1.5 times 300 squared plus 900 times 300. Or we could just do length times width. Check that we get the same answer both ways. Now this one you could do piece by piece, and I see some of you showing your work, but you can also just type it all into the calculator, just using parentheses exactly where you see them. So negative 1.5 parenthesis 300 squared. Close your parenthesis before you square anything, plus 900 times 300. 135,000. Area is always square units, so since it was originally feet, this would be square feet. And then double check, if you multiply those together, you should get 135,000. So I'd like you guys to get together with a partner and try the back one. Let me just briefly take a look at it. This one tells you that you have 500 feet of fencing and you're enclosing a rectangular lot on the side of the highway. The transitive group for California is going to supply the fencing for this side. So you only have to provide fencing around 3 sides, as shown. Okay, so you have 500 feet of fencing and you're enclosing this. You want to find the dimensions that would maximize the area, and you want to find the maximum area. So again, you're going to want to do it similar to what we did on the front, but it will be different. But you are going to be looking at perimeter versus area. Again, don't use a formula since we're not doing all 4 sides. All right, go ahead and move around with a friend and see if you guys can figure this out. If you want to work alone, you can. If you want to work in a group of 3 or 4, you can as well. And I'll be walking around to kind of help you guys.